Right, I don't know about you, but my clock says 11:15. And good morning to you all, and thank you for joining me today. As you might be aware, I'm not in the classroom today, and I am sitting in a room in my home delivering a lesson from there. And I have to say, I'm probably more scared than I was when I delivered your first live lesson, because I'm used to having Miss Francois next to me, and she always manages to keep me calm. So, good morning, Demi Lee. Good morning, Chloe B. So she always manages to keep me calm and stop panicking in case any IT issues come along the way. But we decided that maybe to try and keep ourselves a little bit safer for you, that we would try and deliver some lessons out of school. So here we are. And as you can see, today's lesson, good morning, Livy. Today's lesson, we are going to solve problems involving multiplication and division. Now, over this is our third week, the last 2 weeks, we have been learning the mechanics, the structure, the setting out of calculations involving multiplication and division. But maths isn't always as straightforward as just having a calculation and you carrying it out. Sometimes, good morning, Jay. Sometimes we have wordy problems that we have to find our way through to find the maths calculation that we need to do. And that's what we're going to be looking at today. So we'll be going to applying those multiplication and division skills that we've learned over the last few weeks. Good morning, Chloe D. Those skills that we've learned over the last few weeks, but we're going to apply them to problems, because when you get to year 6 and those dreaded SATs, you always get word problems, and you have to be able to really sort through them, but quite quickly, and realise the maths that you have to do, what calculation you need to carry out. So that's what we're going to be looking at today. Don't forget, if you want to comment, you're very, very good at this now. I don't really need to tell you, it's up here, and you will need a pen and paper. So hopefully you've got the pencil paper. Hopefully you've got them in front of you, because we will be doing some calculations. Good morning, Cole. Along the way, we'll be doing some listening and some active taking part. So let's have a look at our learning outcomes. So our learning outcomes for today are to be able to apply my learned skills. So what are those skills that I've learned? I've learned how to multiply, I've learned how to divide, and I've got to apply them into different contexts. And that's what we need to be able to do. Identify key mathematical information, because sometimes word problems, good morning, Rihanna, sometimes word problems can have quite a lot of words, and you get to struggle to find what's that key. So it's about learning how to pull out that key information, how to look for it, what clues there are, and what you can do and how to recognise what maths calculation you need to carry out. You need to be able to recognise if a problem needs 1 or 2 steps to solve it, because sometimes problems are trickier than others, and it's not just 1 calculation you need to do to solve it, but 2, maybe 3 sometimes, or more. But generally around our learning, it's 1 or 2 step problems. So you also have to recognise when there is a point when you can't stop, that you've solved 1 part, there's another part that you need to solve now, and that can involve different calculations. So it might be a multiplication for part of it, a division for the other step. It might be an multiplication and addition. The operations can be mixed up when it comes to problems, but we are going to specifically be looking at multiplication and division today, so we don't need to worry about addition and subtraction yet. And to be able to solve mathematical problems using multiplication and division. So we know how to do the mechanics of a calculation. Can we use what we know to solve the problems correctly? Okay, so I know you had a fabulous English lesson, so your brain must be buzzing with all that English. So as usual, to start you off and to switch our maths brain on, we're going to start with our maths teaser. And this one is called How Old is Lucy? Okay, so when Lisa was 6 years old, her sister Lucy was half her age. If Lisa is 40 years old today, how old is Lucy? So when Lisa was 6 years old, her sister Lucy was half her age. So we have to know what half is in this context. What is half of 6? And if Lisa is 40 today, how old is Lucy at this moment in time? Over to you. I'll be awaiting your answers with bated breath. Oh my word, Amy, well done. All careful, Harley. Good morning. I don't know whether I said good morning to you, but good morning. Have a go back and think about that question. Oh, this is a nice, easy one for you. Danielle, good morning. Declan, good morning. Correct answers. Oh, Cole and Chloe and Sadia, you need to go back and think about it. Lexi, can you go back and think about it? Think about what you know. Some of those are really, really quick. Amy was fastest finger with the correct answer, followed by Isla, then Declan. Jay, correct, well done. So lots of right answers there. So let's have a look then. So we've got our problem. How old is Lucy? So we have to think about what we know. When Lisa was 6 years old, her sister Lucy was half her age. So Lucy was 3. Oh, John Paul, well done. Never mind, leave. Don't worry about the question. We'll go over the answer together. When Lisa was 6 years old, her sister Lucy was half her age, which meant she was 3. So Lucy was 3, which means she's 3 years younger than Lisa. So if Lucy is 40 years old, Lucy is 3 years younger. All these L's in these names are confusing me. So Lucy is actually 3 years younger. So 40 take away 3 is 37. So Lucy is 37 years old. Good morning, Zidane. Good morning, Summer. Good morning, Aman. Good morning, Solomon. Lovely to hear from you all. Okay, so she was 37 because she's 3 years younger. So we're going to go over our previous learning now. We're just going to have a quick recap on the mechanics of the skills that we learned in multiplication and division. So what we need to know how to multiply numbers up to 4 digits by 1 or 2 digits. So we're going to just quickly go over that. How to divide numbers up to 4 digits by one or a 2-digit number. Again, we're going to briefly just go over those mechanics and how to identify key information in a maths problem. So how do we identify that key information? Okay, time for mathematical talk. What we have previously learned. Okay, so we've previously learned to multiply a 4-digit number by 1-digit number, which is nice and easy. Here we've got 1,403 multiplied by 5. So then we set out this way, 5, and we've got 5 as our, oh, I can't remember that word. I'll have to go back and, is it multiplicand? Yeah, so 5 times 3 is 15. 5, carry our 1. 5 times 0 is 0, plus the 1 that we carried. So 1 goes here. 5 times 4 is 20, so 0, 2. And 5 times 1 is 5, plus a 2 that we carried. So nice and simple. So multiplying a 2-digit number by a 2-digit number. Now I've put that after multiplying a 4-digit number by a 1-digit number because it's remembering that we have to have a placeholder when we multiply a 2-digit number. So here, what we have to do is 26 times 3. So 3 times 26. 6. Okay, so that's 3 times 6, and 3 times, we say 2 because mathematically that helps us, but really it's 20. So 3 times 26, and then because this isn't a 1, this is we're multiplying by 10, we need to remember to put 0 as our placeholder. So we've got 26 times 10, and if we remember multiplying by 10, moving place value to the left, we would know without much thinking that 10 times 26 is 260. And then we have to add these two rows together. So 8 add 0 is 8. 7 add 6 is 13. So we carry the 1. Add 2 add the 1 is 338. So the most important part that you need to remember is that placeholder, because that alters your calculation significantly if you forget to do that when you are multiplying by a 10 number. More mathematical talk. Multiplying a 4-digit number by a 2-digit number. So we progressed, we moved forward from 2 digits to 2 digits to 4 digits and 2 digits. So again, that same process takes place. We multiply 5,108 by 3, by our units number. And then we multiply, did I say 5,008? 5,180. And then we multiply 5,180 by 20. And again, it's remembering our placeholder. This is not 2, it's 20. So we need to put that 0 in our units column before we continue with our multiplication. And then we go along 2 times 0, 2 times 8, which is 82 times 1, or 100, and 2 times 5,000. So we get. And one thing you must remember when you multiply is your answer must be greater than the number that you started with. So if you end up with a number that is less than 5,180, then you probably need to go back and check your answer. In this case, we ended up with 119,140. Good morning, Fatima. Division. So we moved on to division. Last week, we concentrated on division. So 2,340 divided by 4, no remainder. So this is how we set it out. Oh, my calculation, I've put the answer for my calculation. Oh, I'm so sorry. And I checked through this so many times before. So I've put my answer up there. So it should have been 9,360 divided by 4, and our answer is 2,340. Oh dear. So remembering that we say 9 divided by 4. How many times does 4 fit into 9? It's 2. 2 4s are 8, so I've got 1 left over. 13 divided by 4. So how many times does 4 fit into 13? 3 times. 4, 8, 12. Leaves me a remainder of 1. How many times does 4 fit into 16? 4 times, with no remainder, and 0 divided by 4 is 0. I'm sorry about that, folks. We also learned division, 4-digit number by 1-digit number with a remainder. And let's hope I got this one the right way round. Oh, it seems like I did. 4,851 divided by 4. Okay, so again, that's those same steps. 4 divided by 4. 4 divided by 4 is 1. We do not have a remainder because it fits in completely. 8 divided by 4 is 2. Again, no remainder. 5 divided by 4 is 1, and we should have a remainder of 1. So 4 in 11 divided by 4, how many times does 4 fit into 11? 4, 8. I can't get another one because it's 12. So 4, 8, so that's 2. And then the difference between 8 and 11, 9, 10, 11, is 3. So I have a remainder of 3. So that's a run over the skills that we've learned. So let's move on to applying our skills. So Aishin earns £1,213 per week. How much would she earn in 4 weeks? So this is quite a simple one-step problem. And I just need to put that out of the way because that's the bit I've done. So the important information in this question is that Aishin earns £1,213 over, and we want to know how much she would earn in 4 weeks. So that means we need to find 4 lots of 1,213. 4 lots of 1,213. So our multiplication is 4 times 1,213. So shall we pass that over to you? I've given you the calculation you need to carry out. Let's see who can answer that question for me. Over to you. Good morning, Cole. Oh, Amy, that was very, very quick. Excellent, well done. Well done, Lexi. Seconding with the correct answer there. Any other of you nearby with your answer? Or Cole, you just want to check? Well done, John Paul. Well done, Summer. Oh, I know. When we're finding lots of, remember I said, when we're finding lots of, that tells us we need to multiply. Well done, Demi Lee. Well done, Danielle. Well done, Abu. Good morning, Abu. Just give you another minute to try and get your answer through. I like it that some of you are just taking a little bit longer and just getting the correct answer. Well done, Isla. That's it, Cole. Well done. Sometimes it's just how quick we work, doesn't it? Just we make little errors along the way that we perhaps wouldn't. Maybe. Well done, Fatima. You might want to check that answer again for me, Aman. Let's have a look. So this is a calculation. This is how it should have been set out, and this is what it should look like. And I'm sure for a lot of you it did, because I got so many correct answers then. So well done. And 4 times 3 is 12. Our 2, we've carried our 1. 4 times 1 is nice and easy 4, but we've got the 10, the 1 here that we carried, because that's really our tens column. So we add that. So we've got 5. 4 times 2 is 8, and 4 times 1 is 4. So over her period of 4 weeks, she would earn £4,852. And you may think that's a lot of money, but the taxman would take an awful lot of that too. Right, so I'm going to give this over to you. But one thing is important. I want us to do this step by step. What I would like is for you, first of all, before you do any calculating, I want to tell you to tell me what the key information is and what the calculation, what operation will we be using. There are 3,575 counters in 7 containers. How many counters altogether? So, over to you. What is the key information I will need to solve this problem, and what operation? I don't want the answer to the problem just yet. I just want you to be able to tell me what the key information is and what operation you need to use. So, over to you. Remember, I don't want the answer just yet. I just want you to be able to tell me what the key information is and what operation you will need to solve that problem. Well done, Amy. Well done, Lexi. Remember, I don't want you to do the math just yet. I just want you to be able to tell me what key information we need to solve this problem and what the operation is. Excellent, Isla. Well done. So, what operation do we need to use to solve that? Well done, Summer. So let's have a look then. The calculation. Okay, so altogether is a clue that you need to multiply. Okay, so the calculation is 3,575 times 7, because there are 3,575 counters in 7 containers. So we've got 7 lots of how many altogether. Okay, so the calculation. Who can do the calculation for me? With the answer. Oh, Abu, a new fastest finger first. Well done. Abu's got the correct answer very, very quickly. Closely followed by Summer. Well done. Closely followed by Amy, Isla. Amy, do you just want to check that? And Lexi, well done. Any more of you out there? Declan, you're very quiet. Where are you? Danielle, where are you? Fatima, well done. Well done, impressive. You're going to smash this doodle maths task when you get there at this rate. Well done, John Paul. Come on, just check that answer again. That's not 7 times bigger. What you have to remember when you multiply is that your answer should be 7 times bigger than greater than you started off with. Oh, Danielle, just check that. Go through and just check again. It's almost there. There's only one digit. Harley, well done. Right, so let's go over it together then. Your answer should have been 25,025. And we've got that by saying 7 times 5 is 35. 5 carry the 3. 7 times 7 is 49. Add the 3 is 52. So we've got our 2 and we've carried the 5. 7 times 5 is 35. Add the 5 is 40. So 0 here. Carry the 4. 7 times 3 is 21. And the 4 makes it 25. So we have an answer of 25,025. Excellent math skills out there. Well done. So high five to all of you who got that answer. Right. So Rosie wins £5,736 in a competition. Now, Rosie's very, very generous and she's decided that she doesn't really need that money. And she decided that she'd share it, not just, she wouldn't give it just one charity, she'd share it equally between 4 charities. So we've got to find out how much money will each charity receive. Okay, so she's won this money. She's decided that she doesn't need it. Lucky her. And she's not going to give it to one charity. She's going to share it equally between the 4 charities. So over to you again. What is the key information? What information in that problem am I going to need to solve the calculation? And what operation am I going to need to use? So what is the key information? What am I going to work with? And what operation? Don't want the answer yet. I just want us honing in on really getting these skills, really thinking about what is the key information, what operation, and what words are the clues to that. Off you go. Well done, Amy, Summer and Lexi. You've identified the correct operation and then the information that I need to use. Abu, I only want to know at the moment what is the key information and what the operation is. I don't want the calculation carried out yet. I want to, and our learning today is to be able to solve problems using division and multiplication. So it's important that we learn how to recognize what information we need to solve the calculation and the problem and what operation. We need to know those first. Excellent, Isla. So you're all jumping ahead. Well done, Danielle. You've told me what method I'm going to use, the bus stop method, and what information I'm going to use. Lexi, I don't want the answer just yet. I just want to know what operation and what the key information is. And Summer, I love that you've spotted straight away something that I was going to go over when I talked about it, that this word is a real big clue to what operation you need. So let's have a look. Were you correct? Rosie wins £5,736 in a competition. She decides to share it equally between 4 charities. How much money will each charity receive? The key information, as so many of you spotted, was that it's 5,736 and it is 4 charities. So that's our key information. They're the numbers that we're going to be working with to solve this problem. Okay, and operation, she's sharing. So it needs to be a division calculation. Division always means we're sharing out. So over to you, the calculation. Okay, so can you complete that calculation for me? And some of you have given me an answer, and we'll see. We'll see. We'll be checking against the answers that I get. I'm going to check this again now. Okay, so amazing. You're all coming in there really, really quickly with your answers. So that's our calculation. And I want you to think about this. And I have got a different answer to you. Can you tell me why I've got a different answer to you? Can anyone tell me why I've got a different answer? What have I done? My class know that I always do this. I always pop in a calculation where I've made a mistake, so that you are thinking about the steps that you are taking and being able to spot those mistakes as well, because being able to check your work both in maths and English is about being able to spot errors if you've made them. So who can tell me? That's right, straight away Amy is there. My error goes straight back to here. So I've said 4. I've divided 7 by 4, not 17 by 4. So that has completely thrown out my answer. So I've got completely wrong answer because of that error that I made. Instead of saying 17 divided by 4, I've divided 7 by 4. And that, of course, impacts on the whole of my answer. So all of you that got 1,434, well done, thumbs up to you. So each charity receives £1,184. So in my sats, I'm going to get that answer wrong because I didn't stop and check and stop and think. So that's a real thing that we always need to make sure that we're doing, stopping and checking, because it's silly little mistakes that impact on the whole of our answer, and especially in maths where the answer is either right or wrong. So sometimes we're going to think about trickier problems, okay? So trickier problems, they have more than one step, which means that there are two or more calculations to carry out. So we're going to look at a two-step problem, okay? And two-step problems tend to have more of a story around them. So you've got to then start being able to pick out the information. Usually numbers are a clue. Numbers in words, they're usually clues, but you need to make sure that you can always sift through and find the information that you need. Okay, so a group of school children are travelling by train to get to Stratford-upon-Avon. The children are in compartments with 6 seats, so they're in little, because I suppose I've got 6 seats. Each carriage has 13 compartments. Now, trains are made up as carriages. They have the engine that takes you on, and that's one carriage. Then they have another carriage joined and another carriage joined. So all of those parts of a train are called carriages. So each carriage has 13 compartments, so one of these with 6 seats, and there are 14 carriages on the train. How many children are on the train? Wow, I feel blown away by how much information is in there. So I've got to start thinking now of what is really important. Is the fact that a group of school children travelling to get to Stratford-upon-Avon, is that going to help my maths? I don't think so. So I'm thinking that I might be able to just disregard that piece of information for now. The children are in compartments with 6 seats. Well, I've got a number here, so that might be a bit of a clue. So 6 seats I'm probably going to keep to one side and think, is that important? Each carriage had 13 compartments and there are 14 carriages on the train. So again, numbers. So these must be important. And of course, the question, how many children are on the train, that is what I've got to know at the end of this problem. How many of those children were on the train? The key information. I was right. The key information is that there are 6 seats and each carriage has 13 compartments and there are 14 carriages on the train. So now what do I do with that information? So I've got to think, what information comes first? So 6 seats and 13 compartments. So I'm going to work with that information first. Excuse me, very dry. So 6 seats and 13 compartments. So there's 13 compartments and 6 seats. So I'm going to need to multiply. Okay, so I'm going to use 13 and 6 and make my calculation. Okay, so what operation will we carry out? I went a slide too early. 6 seats and 13 compartments. It's going to be a multiplication operation that we're going to carry out. Okay, so over to you, because you're obviously better at this than me, because I keep making mistakes. Go back, go back. Oh, hopefully you didn't see that too quickly. I pressed just one button too many. Can you calculate 13 times 6? 13 multiplied by 6. So 6 seats, 13 times. And if you were really, really quick at seeing the screen, you'll have the answer in no time at all. Amy, well done. My first correct answer. Danielle, a boo. Isla, well done. It's a nice, easy one, really, isn't it, this one? So hopefully when we do my check, I've actually got it correct. Well done, Aman. So let's have a look. Okay, so 13 times 6. So 6 times 3 is 18. 8 carry the 10. 6 times 10 is 60, and one more is 70. So step 1, 78. So I've got this information of 78. Okay. And so now I've used these two pieces of information, 6 seats and 13 seats. 6 seats and 13 compartments. So what have I got to do now? I don't know. Can you tell me what I've got to do now? I've done this part of the problem, and I've got this number here. Anyone any ideas? Can you help me? I'm a bit stuck this morning. Well done, Alex and John Paul. Fatima, you've divided, Fatima, not multiplied. So can anyone tell me what I've got now, what you think I've got to do? What is the next step? I've told you it's a 2-step problem. Step 1, we've completed. What do you think I need to do now? Excellent, Amy. Anyone else? Anyone else tell me what they think I need to do? Excellent, Isla. Oh, Lexi, think about it. What was our learning that we started off? What operations are we using during this problem solving? Okay, so I'll put you out of your misery. So I've got 78 that I need to do something with. So I've got 78, and I now have to multiply 78 by 14. Okay, so I've got 78 seats in each carriage. So now I need to know how many children are on the train in those carriages. My step 2, my calculation should be, and hopefully I won't press too many times and give you the answer this time. So this is my calculation. Now, as just a reminder, I've put 0 in as a placeholder just to remind you that when you get to here, you're multiplying by 10. Some of you might not have needed that, and some of you will find it quite useful. So calculate, can you calculate 14 times 78? Excellent, John Paul. Amy, I don't know how you do it. I really don't. Amy is fastest finger first with the correct answer. I think I can feel your maths brains working. I feel like I'm whirring away. Oh, almost. Aman, just check that. Isla, well done. In there second with the correct answer. Aman, you were closer the first time. Go back and check it. Remember, it's 4 times 78 and then 10 times 78. Excellent, Lexi, well done. All Fatima, you just might want to check that. Remember, you have to do 4 times 8 and 4 times 70. We'll say 7 because that helps us. And then put our 0 in for our placeholder, and then 10 times 8 and 10 times 70. Anyone else? Okay, I'll give you 1 more minute. Well done, John Paul. Okay, so let's have a look. So our calculation should have been 4 times 78. So 4 times 8, which is 32, to carry my 3. 4 times 7 is 28, plus the 3 is 31. So my first row is 312. I've put 0 in as my placeholder, and then nice and easy, 1 times 8, 1 times 7, although it is 1 times 10. But we say 7 because that makes maths easier for our brains sometimes. And then we add them together. 2 add 0 is 2. 8 add 1 is 9, and 7 add 3 is 10. So our answer is 1092. So there were 1092 children on that train. I certainly would not want to be on that train. I'd like to catch the next one, I think. Don't know how to cope with all those children on there with me, especially if they're like you were on so noisy on the coach when we went on our trip. So that's how we work through our problem solving. That's how we apply our skills, looking for what information we need and how to use it along the way. So, to do now, when I practice this lesson, and I practice them lots of times, I thought, oh, won't have time to do your doodle math activity on problem solving. So I took number 1 out, and I just put lunch first, and then I put complete doodle activities for English and math, modular verbs and problems involving multiplication and division second. And then I practiced the lesson another couple of times this morning. I thought, oh, I'm going to finish way early and you're going to have plenty of time. But it seems that I haven't finished that much earlier than lunchtime. So it's up to you now. If you if you do fancy spending the next 10 minutes going on to Doodle Math and start your problem solving, that's fine. If you decide, oh, I might get a few minutes extra lunch, that's also fine. I know you've been working very hard this morning. So have a great afternoon. Lovely being with you, and I'll see you on Thursday. Take care. Thank you for joining me. Bye.